Today we proceed with the next topic, which is the final answer, the last answer, the last chapter in our syllabus, which is the moment and moment generating function. Alright, so for this topic, you will learn again how to find the using the mathematical expectation. Tapi dia berbeza sikit lah mathematical expectation dia ETX dan X power of R. Okay, before this X power of R juga sebenarnya expected of X dan expected of X square. Okay, tapi untuk moment it will be EX power of R. Okay, so it will involve the PDF juga, PDF for discrete dan juga continuous. Okay, so let's see the definition. Okay, so dia kata in this section we concentrate on the application of the moment generating function. The obvious purpose of the MGF ataupun moment generating function adalah to determine the moment of random variables. Okay, you know what is the random variables? We denote the random variable as X ataupun Y ataupun Z, kan? So you tahu what is the variables. Then kita akan dapatkan moment of that random variable. Okay, so how to find the moment? Kita boleh gunakan moment generating function. Okay, so kita tengok first of all, what is moment about the origin? Okay, moment about the origin adalah notationnya adalah mu prime R, which is expected of X power of R. Okay, sebelum ni dalam mathematical expectation, untuk you dapatkan mean dan variance, kan, untuk dapatkan mean dan variance, you cari, untuk dapat mean adalah, notation selain daripada mu adalah it is expected of X, kan, untuk mean. Okay, so untuk cari variance, you need the expected of X square. Okay, so actually ini adalah moment about the origin, which is expected of X power of R. Okay, so let's say kalau kita nak cari X power of 1, so it will call first moment about the origin, X power of 1. Kalau X power of 2, it will call the second moment about the origin. X power of 3, the third moment about the origin. Okay, so the basic concept of the moment about the origin adalah untuk discrete it will be summation of X power of R multiply the function of fx. Sama macam mathematical expectation sebelum ni. Kalau discrete expected of X, kan, kalau discrete it will be summation of X sahaja, okay, multiply dengan fx. Okay, means that you need to multiply each of the X ataupun possible value for X multiply dengan its probability. Okay, you kena multiply each of that, baru you total up. So, you akan dapat mean. So, sama juga konsep kat sini. Sama saja sebab expected of X adalah, actually, mean adalah first moment about the origin. Okay, itu untuk discrete. Kalau continuous, macam sebelum ni lah, you kena sama juga X power of R multiply dengan fx. Okay, you need to multiply these two first, baru you integrate. Integrate with respect to X. Sebab kat sini kita melibatkan function of X. So, dia punya limit adalah depends pada limit of your function X kat sini. Tapi hari ni I nak masuk dulu hanya untuk discrete distribution sahaja. Okay, let's say kalau kita nak dapatkan expected of X square pula untuk discrete, so it will be summation of X square multiply fx. Okay, ini dipanggil second moment about the origin. Okay, so let's say kalau nak cari expected of X power of 3, it will be the third moment about the origin, so it will be expected of X3 power of fx. Okay. So, mu, like I said just now, mu ataupun mean actually adalah first moment about the origin. And variance, which is, we know that variance adalah expected of x square minus dengan mean square. So, it will be second moment about the origin minus dengan first moment about the origin square. Right? So, that is the moment secara generalnya. Tetapi actually we also can find the moment using the moment generating function. If we have the MGF function, we can find the moment about the origin by differentiate the moment generating function. Okay, so we need to know how to find the moment generating function. Okay, so ianya konsepnya adalah expected of e power of tx. Okay, notationnya adalah mxt. Okay, which is expected of etx means that you need to multiply each of the function with etx. Okay, summation sebab discrete. Kalau continuous, function multiply dengan etx, multiply these two first, baru you integrate. Okay, so konsep yang sama dengan mathematical expectation, cuma sekarang sebab kita nak cari expected of etx, so function tadi kena multiply dengan etx, baru you total out untuk discrete. Okay, itu konsepnya untuk dapatkan moment generating function expected of etx. Okay, like I said just now, we can find the moment of origin, about the origin, using the MGF, which is the moment generating function, by we differentiate the MGF. This one, notation untuk differentiate. This is the MGF. Okay, we differentiate the MGF, then replacekan T dengan 0, so you akan dapat the moment about the origin. Kalau differentiate sekali, gantikan T dengan 0, kita akan dapat first moment about the origin. Differentiate lagi sekali, the second differentiation, second order differentiation. Kalau differentiate lagi sekali, gantikan T dengan 0, then you akan dapat second moment about the origin, and so on. Okay. So let's see how to find the moment generating function, and from there, with the MGF function, we can find the first moment about the origin, which is mean, and we also can find the second moment about the origin, which is expected of x square, and then with that values, we can find the variance. Okay, so today I akan tunjuk dulu untuk discrete. Okay, so let's see this example. Dalam your textbook, dia tak buat example untuk discrete. Dia tak buat secara, ada juga sebenarnya, you boleh tengok nanti. Tapi saya nak tunjuk yang general dulu. Dalam tu tunjuk untuk binomial sahaja. But after this, I nak you tunjuk jugalah untuk binomial dan all the special distribution. But before that, I nak focus on this first. If we have the general function of discrete PDF, then how to find the MGF of that function, of that random variable, and from there, from the MGF function, we can find the moment. Okay, so let's see, this is the function for a discrete. Kenapa kita katakan discrete? Sebab kita tengok dia punya possible value dekat sini. Alright, so first thing first, untuk memudahkan you nak kira, nak cari MGF nanti, expected of etx, so put the PDF function ke dalam bentuk table. You have x, we have x. So we have 0, 1, 2, 3. Okay, the function is 1 over 8 multiply 3cx. So the first one will be 3C0 is 1. So the answer it will be 1 over 8. Yang kedua 3C1 is 3. So 3 over 8. 3C2 is 3. So it will be 3 over 8. And 3C3 is 1. So it will be 1 over 8. Is it true? Total of this should be 1. Right? Okay. So now kita nak cari MGF, which is the notationnya MXT. Okay. Which is expected of ETX. Which is summation of ETX multiply dengan PX ataupun FX. Okay, so we should calculate ETX multiply dengan each FX. The first one will be ET power of 0. Kan, X 0. Okay, multiply dengan 1 over 8. Which is the FX. Plus ET multiply 1 multiply 3 over 8. Okay, yang ketiga. E power of t multiply 2 multiply 3 over 8. The last one, E t multiply 3. Okay, then multiply 1 over 8. What you get is E power of 0 will be 1, so it will be 1 over 8 plus E power of t, so it will be multiply 3 over 8, so we can write it as 3 over 8 E power of t plus 3 over 8 E power of 2t plus 1 over 8 E power of 3t. So ini adalah function of MXT for this function. Okay. So maksudnya function of MGF adalah in terms of t. Okay. Akan ada in terms of t. So this is the MGF function for this X random variable. So dikatakan find the MGF for this random variable and use it to determine the first moment about the origin and the second moment about the origin. Okay, which is first moment about the origin actually adalah expected of X. Right? Okay, to find the expected of X, first moment about the origin, we need to differentiate the MXT once, differentiate the MGF function terhadap T once, dan replacekan T with a 0. So, apa yang akan dapat? Differentiatekan this. Differentiate 1 over T terhadap T. It will be 0. Betul? Differentiate 3 over 8 ET with respect to T. So, you will get 3 over 8 ET. Okay, remember how to differentiate this. ET multiply dengan maksudnya first of all just copy the function here ET and then multiply dengan differentiation of the index here terhadap T. So bila you differentiatekan T terhadap T, you akan dapat 1 actually kat sini. Okay, kalau tak ingat, tengok balik you punya info ataupun knowledge about the differentiation of the exponent function, okay, in calculus. So here 2t multiply dengan 2, which is bila kita differentiatekan 2t. Last one, 1 over 8 is 3t multiply 3. Okay, then should be replace all of this, all of the t here with 0. Okay, let's say here 0 0 lah kan, E power of 0 will be 1. So so it will be 3 over 8. Plus, here will be 1 juga, kan? 2 multiply 0 will be 0. E power of 0 will be 1. Then it should be 6 over 8 plus 3 over 8. Yes. Okay. 2, 3. Okay, dah. Okay. So you akan dapat this. Bila kita replacekan t with 0, so you will get 9, 12 over 8. Okay, so you akan dapat min-nya adalah 12 over 8. Alright, so I buat kat bawah ni je lah ya. Actually ni dah tajuk lain. So let's say yang kedua pula kita nak cari expected of x square, the second moment about the origin, which is you need to differentiate the MGS function, the second derivative. Okay, d square over dt2. Okay, terhadap t. Then replacekan t with 0. Means that we need to differentiate yang ni. Tadi dah differentiate sekali dapat ni. So differentiate lagi sekali maksudnya you differentiatekan this lah yang dah differentiate tadi sekali. Okay. So you need to differentiate the MGF function twice. So we need to differentiate this part another one once again. Okay. So differentiatekan 3 over 8 et. So you akan dapat yang sama 3 over 8 et. Okay, plus multiply differentiate pula 6 over 8 e to t. So you akan dapat 6 over 8 e to t multiply 2, right? Plus differentiate pula 3 over 8 e 3t. So you akan dapat kat bawah 1 over 8 e 3 over 8 lah kan sebab dia multiply. So 3 over 8 e power of 3t multiply 3. Then replace all of this with 0. So you akan dapat 3 over 8 plus 12 over 8 plus 9 over 8. So lastly we'll get 24 over 8. Okay, ini adalah expected of x square. So kalau soalan nak you cari variance, ini bukan variance expected of x square, not the variance. You differentiate, you do the second derivative of the MGF, you akan dapat expected of x square, not the variance. Nak cari variance, kena guna formula macam biasalah. So because of we have all these two value, so you bolehlah cari variance. Jadi 12 over 8 square. So you akan dapat the variance. So that is the way how to find the MGF function for the discrete general discrete PDF. And then from the MGF function, we can find the mean and the variance. Okay, so after this, I nak you buat assignment. Maybe next week lah. Okay, nanti I akan inform balik. Okay.